Hello everyone, this is Nathan with Milestone Scholars here, and today we're going to be talking about the fundamentals of Euclidean geometry. Starting off, we have points. So when you look at a TV, for example, you see a color picture being shown. And this picture is actually demonstrated by millions of color points behind the TV. It consists of red, blue, and green, those colors for your reference. And those color pixels are points. So a point in geometry is represented by a dot like this. And we're going to call this dot, point A. So point has no length, no width, no height. It's just a simple point. And next we're going to talk about lines. So let's say let's draw a point here. Let's have a point here. So let's call this line AB. So line AB. So as you can see here, a line is something that is straight and continues on in opposite directions indefinitely. So as we can see here, as it approaches point A here, it still continues on. And as it approaches point B, it also continues on. And I draw the arrows to indicate that they go on forever and it won't stop. So next we're going to talk about a segment. So segments really are just the opposite of lines. So I'm just going to draw a segment here. Let's call this point C. We're going to call this point D. We're going to draw a line right through it. So this we will call segment CD. So a segment, as you can see, when this line, which is also a straight line, approaches point C, it stops right there. And as this part approaches, as the part of the line approaches point D, it stops there. So that's the basic idea of a segment. Next, we're going to be talking about rays. So rays are almost like a combination of both lines and segments. So rays really, we're going to be drawing point E. Let's also draw point F. It's horrible F. Okay, we're going to draw a line straight through point F. So as you can see, it takes on both properties of lines and segments almost. And it stops at point E as demonstrated here. However, when it reaches point F, it goes on indefinitely, as represented by the arrow here. Next, we're going to be talking about planes. So planes are just, if you really think about it, like a dimension in geometry almost. So if we draw a plane here, let's just call this plane P. That's a horizontal plane right there. I can draw points in it. I could draw lines in it. So anything can exist in a plane, except for three-dimensional figures. And this is, for your reference, a vertical plane. Now we're going to talk about two terms, collinear and coplanar. So collinear basically means that it can be connected by a line. So let's bring back line. I'm going to draw point A here. We're going to utilize point A and B again. So point A and B, these 2 points are collinear. The reason behind that is because they could be connected by this line here. So if I have, again, using point A and point B, we're going to add another point C. These 3 points are not collinear, but A and B are collinear, B and C are collinear, A and C are collinear as well. But these 3 points cannot be joined by one straight line. So yeah, these are not collinear. But if I have sorry, that is a horrible point. So if I have point A here, we're going to draw point B here. We're going to draw another point C here. So these 3 points are collinear as they can be connected by this line right here. So that is the idea of collinear. Moving on to coplanar. So coplanar basically means that they exist in one plane. So let's say we have point P again. Plane P. Label this P. So let's have one point here, another point here. So this point, this point, this point, all three of these points are coplanar. So if I draw a point, for example, point Z right here, so this is point Z, one I just circled, this point is not coplanar with these 3 points because it is outside the plane and doesn't have to do anything with this plane. So coplanar really, so the fundamental idea is that anything that exists in the plane is coplanar. And you're not restricted to using only points. You could also use, for example, lines. You could also use, for example, points. You could also have, for example, rays. All 3 of these objects I just drew are coplanar. Now, we're also gonna talk about how planes intersect. So for example, if I have this plane right here, let's call this point P again. Now we're gonna have another point. We're gonna draw another plane. We're gonna draw a vertical plane. So this plane we're gonna call plane Q. So these planes intersect at this line right here. We could just call this line Z. These points just intersect at that line. So if I was to give another question, how could, for example, 3 points intersect at one line? Just take a moment to think about that. How could 3 points intersect together? Well, the answer to that is that I could, for example, draw a point a plane right here. I'm going to call this plane P again because why not? We're going to draw another plane right here. We're going to call this plane Q. So these 2 planes intersect at this line right here. How do we draw the 3rd plane? So you could either, for example, So you could either do this, and as you can see, it's almost like a hidden plane right there. We can call this plane A right here. So it's like a hidden plane right there, or you could, let's, for example, erase this. You could also have a plane right here. There's also a plane, so we can call this a plane B. So there we go. I just drew 4 planes intersecting on one line. That's basically Euclidean geometry, and these are basically fundamentals that you probably have learned before, but it's a good review. And thank you for listening in and for watching. Thank you.